Hi, in this video, we're going to be working with all four of our sinusoidal transformations. Now, something to note that's important is period and phase shift. Period needs to be factored out. We don't want this B mixing in with that C, and it can look like they are mixing together sometimes, and we need to separate them. You can see here we don't have those parentheses, but it's okay because our B value is 1. However, here, this is not C. That is BC. It's B and C multiplied together. We have to factor out whatever that B value is, just like you can see right here. It's not 2 pi over 3 as our phase shift. It's pi over 3 as our phase shift. So if you do notice that you have a non-1 for your B value, double check that it is not there should be a parentheses there. Make sure that parentheses is there. So let's try one. Oh, here's an example where that's happening. I've got this 2 and that pi. That pi is being multiplied by our B value. So we have to factor that thing out. So let's do that. So we're going to rewrite this as y equals the sine of 2 and then a parentheses and then our x. Plus, well, if we divided that 2x by 2, we better divide that pi by 2 as well. So then we get pi over 2 for this one. Okay, so just basically always divide out whatever your B value is. Speaking of B value, let's write it down. Our B value is 2, making our period to be 2 pi over 2, which is just going to be a pi. All right. Our C value, it doesn't really exist. It's like a plus 0, so nothing doing there. Oh, wait, that's our D value. Oops. Well, at least I caught it. So this is 0. So we're going 0 with our sinusoidal axis. Our C value, that was the one that was causing us trouble. It is pi over 2, and we want to shift that to the left because it's all backwards and weird on the inside of that function. Our amplitude, our A value is 1, so that's far up and down we've got to go. So here we go. Let's graph it. I'm going to be going to the left, so I'm going to need a little more space over here. I'll get to there in a minute, though. 1, 2, 3, 4. Write down my period, which is pi, and then halfway is pi over 2. Our sinusoidal wobble is going to be going up and down. 1 and down to -1. And then I need to go pi over 2 to the left. Well, it seems like I've got 2 ticks. 1, 2 ticks is going to be pi over 2, and I got to go to the left. So I'll go 2 ticks to the left to get to negative pi over 2. And that is where we're going to start our sinusoidal wobble. So we'll start right here on, then up, then on, then down, and on. And since I got the other tick marks, I might as well just keep wobbling. Woohoo! All done. In this one, B and C are not behaving themselves. You got it. You can't hang out together. You got to separate yourselves. So let's factor out that B value. So we get 4x minus, we want to divide that 4 pi by the same 4 that we divided x by, our B value. So that's just going to be pi plus 1. So that 1 is our D value, so that's going to be 1 up. Our phase shift is pi. That's going to move it pi to the right. Right? Why would you do that? Right. Our B is 4, making our period that 2 pi over our B value, which is a pi over 2. Right? Yeah. Okay. Then our amplitude is -3. So let's see, that is going to be up and down 3, but it is going to be flipped because it's negative. So we'll just have to remember that rather than going up first, we're going to go down first. So we'll just kind of make a little adjustment up here for that flip. So we'll go wee like that instead. Okay. So here we go. We're going pi to the right. So I want to have space over there and I want to go up a little bit. So here I'll go like that. So 1, 2, 3, 4, write my period. And then pi over 4. And I want to go, oh gosh, I want to go pi to the right. I don't have that kind of space. What do you think? I'm made out of space? Pi to the right. I want to go 2 periods to the right. And since this thing wobbles infinitely, that pi to the right really doesn't do anything because I would take this point and I would move it to here and another one would take its spot. And then I'd move it to here again and another one would take its spot just as before because you got to remember this thing is infinitely long in both directions. So that pi to the right isn't going to really do anything. So I'm going to ignore it because it would have gone, whoop, let me draw it. It would have gone, whoop, whoop, but a point from over here would have just filled in its spot. That pi to the right is not going to do anything. So I'm going to ignore. If you really want to, you could draw a super wide graph. You can have fun with that, but I'm not going to do that. I don't have enough space. I'm going to go up 1. Normally, I don't give you examples that are that far off, but let's see. I want to go 1, 2, 3. So 1, 2, 3 down to -2, and then 1, 2, 3 up to 4. I'm ignoring my phase shift. So later. So we go on. I can't ignore my flip though. Down, on, up, on. And there we go. Okay, I felt it. I felt it. People didn't like that idea of what I was talking about, so I made this thingy. So I graphed our original one, and just to make sure that you're cool with what I did, is I factored it out, and you can see that that doesn't change anything. So we get that same thing. Now, watch what happens. If I get rid of that minus pi, it doesn't matter. And then I made this because I was feeling really adventurous. Watch this. So this one is going to move and it's going to shift back and forth between negative pi and pi. And you'll see that every time that it kind of hits a pi, it lines up because that thing is infinitely long. So as it shifts left and right, it don't matter. It don't matter because it just kind of fills in the gaps. Isn't that cool? Oh, I hope you appreciate this cool animation. Oh, now I'm going to get rid of it before I throw up. All right, in this example, B and C, what have I told you about hanging out together? I have told you, and I have told you, but you cannot be together. Get out. No. No. Now, the pi over 2 gets divided by a pi over 2. Pi over 2 divided by itself, oh, that's just 1. Whoop. -2. -2, guess what? You're our D. So that is going to be 2 down on our sinusoidal axis. So all of our points need to move down 2. Our phase shift is going to be 1 to the left. 1 left. And then our B value is going to be pi over 2. So our period is going to be 2 pi divided by pi over 2. So if I try to simplify that, I could multiply out the divide by 2. So that would be 4 pi over pi. But hey, wait, then the pi's cancel. So our period is 4. Oh, neat. Well, guess what? That's just a number. All right. Our amplitude is just A, so that's just 1. 1. Well, hey, now we don't even have goofy pies going on. I know exactly where 4 is. You go 1, 2, 3, 4, and then you write a 4. Oh, wow. Don't freak out because guess what? Our C shift is a nice whole number too. Ah, thanks, friend. We want to go down 2, so we'll do our sinusoidal shift. 1, 2. So -2. Bop, 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 bop. Our amplitude is 1, so we want to go up and down 1 from this point, from this line. So we want to go -3, and we got to go to -1. And then we want to shift 1 to the left. Ugh, I don't have space over here. -1. Left to right there. Once we got there, time to do our pattern. So on, up, on, down, on, and an extra up just for fun. And there is our sinusoidal curve. So ends our sinusoidal transformation video. So here's the slide that we started out with. I added on, if you haven't noticed, there's a pattern to doing these transformations. You'll always do them in the same order. First, you will be graphing your period, followed by making your sinusoidal axis for any vertical shifts that happen. Next, based on where your sinusoidal axis is, do your amplitude up and down from the sinusoidal axis. Shift either left or to the right for your phase shift, and then finally make your wobble, either the sine wobble or the cosine wobble. Don't do all those steps and then choose the wrong wobble. Thank you for watching and have a great rest of your day.